One of the horrific events in the history of Kazakhstan was the tragedy of Sympalatinsk polygon. Our presentation will tell you information about the Sympalatinsk polygon and its impact on the environment and human, and specifically population which lives nearby regions. Let's start with our outline. First of all, we will tell you about the historical background of Sympalatinsk polygon. Then we will move to the scientific explanation of nuclear testing's danger. Third, we will tell the types of the pollutions on the environment. Then we will move to the human impact and consequence of nuclear testing. After that, we will tell you about the treatments and recovery processes which the government of Kazakhstan do in order to overcome this problem. Then we will tell you about the forecasting and statistical analysis of this event, and we will move to the conclusion. First of all, let me start about the Sympalatinsk polygon. Sympalatinsk polygon is also known as the polygon, was the primary testing venue of the Soviet nuclear weapons. It was opened on the initiative of the Soviet Politburo in accordance to the entering of the Soviet Union into the Cold War. There were tested 456 nuclear tests, and it was located in East region Kazakhstan, and specifically nearby the Semey city. As I told, there was 456 nuclear tests, and 136 tests were done in an area. The area of the Sympalatinsk polygon contains more than 20,000 square kilometers. It was one of the horrific events in the Kazakh history, and specifically which make the people to overcome this problem. Therefore, such horrific events as the Sympalatinsk polygon gave a rise to the Nevada-Sympalatinsk non-governmental organization, which contributed to polygon shutdown in 1991. First of all, let me tell you about the nuclear test as the exposure of radiation. Radiation is the emission of energy in the form of energy and particles. It exists and transmits everywhere, but it has a different spectrum and concentration which indicate its danger. So, let me demonstrate you a graph here, so we can see that radiation measures in sieverts, and 0.01 sieverts is the minimum dose of radiation, and the death level of the radiation is 10,000 microsieverts. Therefore, it can be stated that actually, according to the statistical analysis, during the exposure of the atomic bomb, more than 10,000 microsieverts explode into the environment. Therefore, it would be deathful for the population which lives in nearby regions. Radiations divides into three types: alpha, beta, and gamma. What is the difference between alpha, beta, and gamma? You can see that alpha is the weakest one and gamma is the most dangerous. Nuclear test as exposure of radiation. Ionizing radiation is a type of radiative exposure which occurs during nuclear tests. Gamma and beta radiations are emitted during exposures. The huge emission of super relativistic particles has a horrific impact on living organisms and environments entirely. The Sympalatinsk polygon is a great example of such case. Let me move to the pollution. During the nuclear tests, two types of the pollution occurs. First of all, it's the exposure of such elements as iodine, cesium, radium, which are related to the radioactive, CO2 pollutions, and products of the fusion of nuclear fuels, such as dimethyl hydrazine, and actually thermic pollutions. As you know, the environment is actually co-integrated. Atmosphere, hydrosphere, and lithosphere interconnects to the biosphere, and it is actually chained by a sphere. Let me tell you about the air pollutions. According to the air pollution is very horrific events. Large quantities of atomic isotopes which emit during explosion of atomic block accumulate in hemisphere. It influences the change of atmosphere and composition. Dynamic movement of air masses spread hazardous elements. Therefore, it influences on such cases as lithosphere and hydrosphere, and consequently influence on the human and other biodiversity.
As to the lithosphere pollutions, soils accumulate dangerous particles. Such isotopes of radioactive elements occur in organic tissues of plants. Also, it poisons plants and animals through feeding process, and more than 25,000 kilometers per square of semi-Palatinate polygon lands were poisoned. Moving on to the hydrosphere pollutions. Pollution of the hydrosphere is a major problem. When we think of pollution, we sometimes only think of things like plastic bottles, oil, and so on. But any chemical that is present in the hydrosphere in an amount that is not what it should be is a pollutant. Animals and plants that live in the Earth's water bodies and are specially adapted to surviving within a certain range of conditions. If these conditions are changed, for example through pollution, these organisms may not be able to survive. Pollution then can affect entire aquatic ecosystems. The most common forms of pollution in the hydrosphere are waste products from humans and from industries. Nutrient pollution, for example, fertilizer runoff, which causes eutrophication and excess of nutrients in the water, leading to excessive plant growth and toxic trace elements such as excessive plant growth and toxic trace elements such as aluminium, mercury, and copper, to name a few. Most of these elements come from mines or from industries. In our case, interconnected chain of water resources brings radioactive elements to other water reservoirs, so radioactive lakes occur. Moving on to the impact on human, dangerous particles get into organisms through feeding, breathing, and translocation processes. Getting into organism, they destroy cells and DNA chains. Organism treats damaged parts of DNA through copywriting process. However, this process could lead to mutations and somatic diseases. Some particles could be accumulated in organism for a long time and poison them for a long time period. As to the radiation effects of human irradiation, the genetic effects are radiation sickness, such as like local radiation injuries, leukemia, or tumors of different organs. And as to the somatic effects, these are gene mutations, chromosomal aberrations. Also, radiation and human organ system. The poisoning with radiation causes in 4 stadiums. First one is prodromal, outage of digestive system. Second one is latent, fake improvement of health conditions. Third one is manifest illnesses, like sharp outage of all organ systems. And the last one is recovery or death, depends on immune system. Statistical information on risk cases and illnesses connected with nuclear tests, like 2008 study by Kazakh and Japanese doctors concluded that the pollution in semi-Palatinsk and surrounding areas received more than 500 millisieverts of radiation in one exposure. In comparison to the USA, where the average American is exposed to about 3 millisieverts of background radiation each year. With the advancement of technology, there are signs of radiation. However, the amount of radiation emitted from the nuclear testing supersedes that of a laptop or other electronic device. Radiation has had a profound effect on the people of the region in that it has altered the way they live. A majority of the 220,000 affected people were exposed to an estimated dose between 7 millisieverts and 350 millisieverts. The Kazakh and Japanese doctors noted that the rate of cancer of those living in the region remains 25-30% higher than elsewhere in the country. In fact, cancer rates in the area of Semi-Palatinsk are twice as high as the national average, and it is estimated that birth defects are up to 10 times higher. There is a higher chance of mental deficiencies in children born to parents who were exposed to radioactive fallout from the testing. Also, this includes nightmares, depression, frustration, agitation, and more, while the physical toll includes hemorrhaging of respiratory tracts, mouth, genitals, and changes in mucus and skins. These tests also impacted the environment negatively by altering the land. Crops could no longer grow as they did before, and water was now polluted with radiation. The nuclear weapons test at St. Watkins inflicted serious damage to the area around the test site, as it left large pieces of agricultural lands in Kazakhstan radioactively contaminated. Lake Chagan, or Atomic Lake as it is known to the residents, is a direct result of consequences stemming from nuclear testing. The lake was produced by an underground explosion that formed a reservoir. However, the water is radioactive, about 100 times more than the permitted level of radionuclides in drinking water. This proved to be hazardous for the civilians who needed the water for everyday life. Concerns of Soviet citizens of the blast contaminating the environment prompted the Soviet Union to scale back its nuclear testing program.
Final explosion. On 29 July 2000, the last of the nuclear test infrastructure at the former Semipalatinsk test site was destroyed. This final explosion completed a 5-year Kazakhstani-US cooperative threat reduction project to eliminate the site's infrastructure. The explosions were used by the international monitoring arm of the CTBT to identify nuclear explosions more precisely in the future and to distinguish them from earthquakes. U.S. Deputy Assistant Secretary of Defense Susan Koch signed an amendment to increase U.S. funding from $26.5 million to $33.5 million. Measures taken. In 2000, there was the first phase of cleanup completed. According to Shamil Tuhavitulin, director of the National Nuclear Center, the first phase of cleanup at the former Semipalatinsk test site has been completed. The cleanup work was carried out under an agreement between Kazakhstan and Russia. From 1998 to 2000, 1/3 of the test site territory was examined. In 2001, Kazakhstan marks 9th anniversary of closure of Semipalatinsk. On 29-31 August 2001, an international conference entitled 21st Century Towards a World Free of Nuclear Weapons took place in Almaty. Kazakhstani President Nursultan Nazarbayev asked for international assistance to clean up this test site. Cost of recultivation and cleanup of radioactive soil could total be $1 billion. Kazakhstan had received around 20 million in aid for cleanup efforts. In 2002, UN launched 38 projects to rehabilitate Semipalatinsk region. On 25 November, the 75th session of the UN General Assembly adopted Resolution 101 on international cooperation for the humanitarian, ecological and economic rehabilitation of the Semipalatinsk region of Kazakhstan. In keeping with the resolution, the United Nations is implementing 38 socio-economic and environmental projects to rehabilitate the region. In 2003, there was a radiation monitoring laboratory to be opened in Kazakhstan. On 6 February 2003, ATR TAS reported that a laboratory will be opened in the city of Kurchatov, which is located in eastern Kazakhstan Oblast, to monitor the radiological situation at the former Semipalatinsk test site. According to Larisa Ptitskaya, the provision of Semipalatinsk with special status and transfer of site management to the Kazakhstani National Nuclear Center, which would coordinate research activities and security measures at the state, was under consideration of February 2003. In 2003, International Atomic Energy Agency recommended that a comprehensive assessment of the former Semipalatinsk test site be developed. SCG members are developing recommendations to implement UN General Assembly Resolution number 53, which calls for international cooperation. IRC summary of the situation in perspective for the future. At the present, the SNTS doesn't negatively impact the population with the exception of the zones of influence of the river. However, the radioecological situation is not still stable. Process of migration of radioactive substances have been identified, and this makes it necessary to conduct regular monitoring of the radioecological situation at the SNTS. This should result in up to 80% of the territory of the SNTS being returned to the community for regular economic use. The remainder of the territory, the remediation of which is economically infeasible, should be enclosed and marked with warning signs about radiation dangers. In those areas, regular radioecological control should be conducted. The Semipalatinsk test site was the primary testing venue for the Soviet nuclear weapons. In conclusion, we can say that as a result, more than 56,000 of cases of cancers and 75,000 cases of genetic anomalies occurred. Even now, the radioecological situation is not stable. Processes of migration of radioactive substances have been identified, and this makes it necessary to conduct regular monitoring of the radioecological situation at the SNTS. The remainder of the territory, the remediation of which is economically infeasible, should be enclosed and marked with warning signs about radiation danger. In those areas, regular radioecological control should be conducted. Thank you for attention.